as inappropriate. There was a noticeable increase in the levels of defects over the period 2012 to 2015. And contractors were neutral to satisfied with the performance of clients on 18% of the project surveyed. Contractors are neutral to satisfied with the quality of tender documents and specifications obtained from clients on approximately 17% of the projects surveyed. And the report continues. Contractors were neutral to satisfied with the management of variation orders on 24% of the projects surveyed. 60% of payments to contractors were made for more than 30 days after invoicing. The recommendations of the tender committee were overruled in the award of approximately 9% of public sector projects. H&S on construction sites as well as transportation to the sites remains a concern. The transportation to the sites being a health and safety issue, as such transportation is deemed to be in the course of employment. The fourth industrial revolution, FIR, also known as Industry 4.0, it's a collective term for technologies and value chain organization which draw together cyber physical systems, the Internet of Things, IoT, and the Internet of Services, IOS, together with other emerging technologies such as cloud technology, big data, predictive analysis, artificial intelligence, AI, augmented reality, AR, agile and collaborative robots, and additive manufacturing. Autodesk and the Chartered Institute of Building, in a landmark report published in 2009, state that digital technologies are transforming every industry, and construction is no exception. Given the general level of performance in South African construction, the advent of Industry 4.0, and the limited research that has been conducted relative there to study the potential contribution of Industry 4.0 to the construction industry was conducted. The objectives relative to this paper, please note, Chair and delegates, relative to this paper, reports on a component of the study, and they are to determine the extent to which factors contribute to the late completion of projects, quality non-conformances, and poor productivity. And secondly, the extent to which Industry 4.0 interventions could mitigate the factors contributing to those phenomena. The research method and sample strata, the study was quantitative in nature and entailed a web-based questionnaire survey conducted in the building sector of the construction industry in the city of Port Elizabeth, South Africa. The questionnaire consisted of 26 questions, most of which were 5-point Likert scale type questions. Of the 60 registered construction professionals requested by means of an email to participate in the study, 30 responded, which equates to a response rate of 50%. 57% of respondents were construction project managers and 43% were construction managers. 90% of respondents were male and 10% were female. 23% of respondents were less than or equal 40 years of age, and 77% were greater than 40 years of age. Just for the record, the definition of an older worker is over 40 years of age. That's the global definition. 13% of respondents have 10 or years less work experience, and 87% have more than 10 years work experience. 40% of them possessed a master's degree, 20% a Bachelor of Technology or honors degree, 30% a diploma or bachelor's degree, and 10% a national certificate or less. Table 1, which is in two parts, A and B, presents the extent to which factors contribute to the late completion of projects. There were, you will note, a total of 23 such factors, and you'll note from 23rd that all the mean scores of the factors are greater than 3, which means that the factors contributed to more of a major extent than a minor extent in terms of the late completion of projects. It is notable that 3 of the 23 factors have mean scores greater than 4.2. In other words, those mean scores occur in the range, the upper range, a near major to major extent. So if you're looking at columns 4 and 5 relative to the first 3 factors, you'll see most of the responses are in those 2 or relative to those 2 points. So 4.45, 4.40, and 4.23. Rework ranked first, poor decision-making second, late provision of information. Also notable that there were, in fact, a further 5 factors that have mean scores of 4.2, which, of course, is the upper point of the lower range. So they kind of straddled the upper 2 ranges, and they are poor site management, poor coordination of subcontractors, underestimation of the complexity of the work, inappropriate coordination information, and poor site supervision. Just to note, table 1B, transportation delays are ranked last, and shortage of plant and equipment second last, and poor procurement strategies third last. However, as pointed out, they all have mean scores greater than 3, and in fact, those last 3 occur in the range greater than 3.4, less than or equal to 4.2. Moving on to the extent to which factors contribute to quality non-conformances, you will note that there are 20. All the mean scores are greater than 3, which means they contribute to more of a major than a minor extent to quality non-conformances. It is notable that only 2 factors have mean scores that occur or fall within the upper range of greater than 4.2, less than or equal to 5. That is a near major to major extent, inappropriate / poor design, and poor site supervision. So there we have a designer, and there we have a contractor factor in the first 2. Poor decision-making, poor site management, improper construction methods implemented by the contractor, poor coordination of subcontractors, poor coordination on site, inadequate planning, inadequate project management system. So that's an overarching factor, and is obviously project management related. Incomplete documents. So it's quite clear that all stakeholders are contributors in terms of the factors which contribute to quality non-conformances. Table 3, in 2 parts, presents the extent to which factors contribute to poor productivity. There are 25 such factors. Once again, all mean scores are greater than 3, which means that the factors contribute more of a major than a minor extent to poor productivity. It is notable that 5 of the factors have mean scores that fall in the upper range, greater than 4.2, less than or equal to 5, and near major to major extent. Poor decision making is ranked first. That's a general. It's not specific to any stakeholder group. Rework, improper construction method implemented by contractor, late provision of information, poor site supervision. Also notable, as in an earlier table, there are factors that have mean scores of 4.2, the upper point of the lower range. In this case, poor communication, inadequate planning. Moving to the last again, transportation delays is ranked last, poor material handling, second last, poor procurement strategies, third last. But yet again, they have mean scores above the midpoint of 3, and in fact, greater than 3.4, less than 4.2. The table, or table 4, not the table, table 4 presents a comparison of the perceived extent to which 11 Industry 4.0 interventions could mitigate the factors contributing to poor performance on projects. So as we can see, there's a late completion column, quality non-conformances column, poor productivity column, and then a mean column on or to the extreme right. I'm just going to address the mean, and because that gives us an overall impression. Notable that all the mean scores are above the midpoint of 3, which means they can contribute to a more of a greater than to a minor extent to mitigate those factors. So building information modeling is ranked first. Joint second, implementing a smart construction site and 3D printing of building components. Augmented reality joint fourth with use of radio frequency identification, autonomous vehicles that deliver material. 6, automation and robotic technology to replace workers involved in physically demanding work. 7th, use of drones to conduct inspections and monitoring. 8, VR. 9, big data technology. 10, cloud computing. 11. So, the conclusions. Given the size of the sample stratum, the response rate, and that the potential of Industry 4.0 interventions to mitigate the factors contributing to poor performance on projects is perception-based, the findings cannot be considered definitive in any way, but rather indicative. Given the extent to which factors contribute to the late completion projects, quality non-conformances and poor productivity, can be concluded that performance relative to the 3 parameters is poor. The factors are largely common, and the empirical findings reflect those identified in the literature. Furthermore, the factors that contribute to poor performance relative to parameters do so indirectly via other parameters. In other words, rework, which is a result of a quality non-conformance, marginalizes or militates against productivity. Further conclusions, given the perceived extent to which 11 Industry 4.0 interventions could mitigate the factors contributing to poor performance on projects, it can be concluded that there's potential to improve performance relative to the 3 parameters. Industry 4.0 technologies are perceived, not confirmed, are perceived as having the potential to contribute to such improvement, and simultaneously relative to all the parameters. Research which is perception-based supports the findings reflected in the literature. Recommendations: the benefits of 4IR and the technologies and advancements need to be welcomed and introduced into the built environment and on projects in general. Employer associations, professional associations, and statutory councils should raise the level of awareness relative to the potential implementation of 4IR in the built environment and should promote and facilitate related CPD. Case studies entailing the deployment of 4IR technology should be documented, the findings shared, and of course this is likely to consolidate the positive perceptions with respect to the potential of such technologies. Tertiary built environment education programs should integrate such technologies into all possible modules, and statutory council accreditation panels should review same. A range of interventions are required to realize effective digitalization of construction. A strategy is necessary to avert piecemeal implementation of such technologies so as to optimize the synergy between them. And of course, employees need to be upskilled to consider how they can use such technologies to address the issues in the form of the factors that contribute to poor performance, as opposed to just being able to use the technologies. Of course, acknowledgement of the problems is a prerequisite for resolving the problems, and hence the questions proposed during study. Problem-solving skills are also a priority, given the extent to which the factors contribute to poor performance. Thank you, Chair. Oh, there's further recommendations. Tertiary education institutions will have to develop a code of digitalized graduates to meet the demand for new specialized roles and responsibilities. Furthermore, construction activities should employ greater mechanization, automation of laborious, tedious, and often hazardous tasks. And doing so is likely to contribute to improving total productivity. And of course, total productivity includes labor productivity, material productivity, and plant and equipment productivity, and productivity of the use of capital. And of course, also lastly, the meeting of schedule requirements. Thank you.
Thank you, Prof. That was a very good presentation, actually. I did listen, although I'm not in the construction industry, but I see the fourth industrial revolution stuff you are presenting, and I see that it is actually very useful. I listened to your recommendations, and I do quite agree with what you have recommended there, that it should be useful. Given the fact that you considered about 23 different quality parameters, the non-conformances and all that. I see that it's something that should be looked into and probably integrated in the construction industry. It's a job well done. So I want to check now if we have people that have questions for you so that you can attend. There are no chats. Okay, Prof. There are no questions. I can only say it's a good work and then we should even improve on this. There is a question.
Thank you, Chair.
Is there anybody raising? Okay, there's a lady with a question now. Can we hear you? Hello.
Hello, everyone. This is to Mr. Smallwood. I just would like to get your understanding of the correlation between the compromise negotiation of the construction time and cost and the quality of projects that you managed to do analysis on.
I'm not sure what you asking.
Basically, from my experience regarding the construction industry, I'm an architecture student. So what I've seen is that you have a majority of clients, for lack of a better example, I would cite government projects wherein you get 40 to 50% discounts on construction projects for the professional team who are the ones who are issuing information and they're project managing and they're doing a lot of the work that gave you an MS of 4 and above, right? So in that respect, did you ask that kind of question to professional providers? And was there a correlation between their compromised construction times and cost in relation to the quality of the projects at the end?
When I commenced with the presentation, I recorded the objectives. I also, prior to that, highlighted that it was a BSc honors level study. And generally, in terms of honors level studies, we do not conduct inferential statistical analysis to determine correlations and associations. That's just a generic comment. Secondly, as pointed out during the presentation of the research method and sample stratum, construction project managers and construction managers were surveyed, not designers and quantity surveyors, and for that matter, obviously landscape architects and interior designers that have been included in that generic designer group. But just to highlight, yes, the whole issue of designers and quantity surveyors being pressured to reduce fees or so-called professional fees, research has been conducted relative there too. And obviously, the designers have now joined the ranks of contractors because the contracting sector, not only in the South African construction industry, has had to deal with this for decades, if not a century, due to the competitive tendering process, which predominates which is the traditional construction procurement system, as we refer to it, predominates in South Africa. So yes, but of course it has a lot of implications because the design practices and quantity surveying practices are being paid less to deliver the same service. So the problem or the phenomena that result therefrom are obvious. It's not to say that prior to this, when there were fixed fee scales, designers didn't err in terms of designs, details, and specifications, and of course, marginalize constructability, which many designers do. And of course, that in turn is attributable to the fragmentation of the delivery process in the construction industry. In other words, if you buy a motor vehicle, you don't approach a designer and then a lead designer, say, and appoint a mechanical engineer, an electrical engineer, and a structural engineer for the chassis, etc. It's a one-stop service, and hence the importance of construction delivery systems or procurement systems that integrate the design, procurement, and construction processes. But this country, as most of us know, lags behind developed countries such as the United Kingdom in terms of integrated delivery systems. So I hope I have answered your question.
Thank you, Mr. Smallwood.
Thank you, Professor Smallwood. Thank you for that. That was wonderful. Now, we move to the second paper, and the authors are Ashvin Manga and Chris Allen. Are you here?
I am, Chair.
You are here. Title of the work is Data Analytics for Improved Indoor Air Quality. Can you just share your screen, please?
Can you see my screen, Chair? Okay, we'll try that again.
We can't see your screen yet.
Okay, I'm trying to share it again.
Yes, it's coming up. Yeah, it's on now.
Okay. Okay, so hello and welcome to everyone. It is my honor to present at this year's 9th International Conference on Appropriate Technology. And this could not be a more appropriate topic, bearing in mind the year 2020 and all that we have had to endure. This research was conducted as part of a BSc Honours in Construction Management in the Department of Construction Management at Nelson Mandela University. My name is Chris Allen. I was the initiator and supervisor for the study, which was conducted by Mr. Ashvin Manga. The research effort investigated the change in indoor air quality through a case study of a commercial office building before and after a window retrofit was carried out. The focus of this paper is on the data collection and analysis process and not the entire study, and in particular the impact of the data on understanding the internal air quality and thus informing better management of the indoor environment. It seems fair to think that in the year 2020, after 5,000 plus years of constructing buildings, that we should be able by now to get the indoor environment right. But that is not necessarily the case. So with 2020, the year of COVID-19, and the impact of airborne virus carried in liquid droplets being very at the forefront of our minds, this has become something of a focus for a lot more people. We have been forced to reconsider all that have been previously accepted as normal and to rapidly adapt to a new normal. The indoor air quality and ventilation may profoundly impact the spread of the disease within our built environment, and there has thus been much discussion concerning the importance of this in our buildings. However, this is not the first virus that spreads via the air we breathe, and it won't be the last. So we need to consider that when we are looking at our built environment. Rather than focus on a single virus, we should rather focus on the health of indoor built environments and how we better manage the quality of the air within it. Going back to first principles thinking, we can begin by reviewing an axiom that we know to be true. Humans on average take as many as 24,000 breaths each day. Considering the average volume of a human breath is 0.5 liters, we are breathing in approximately 12,000 liters of air each day. In order to visualize this, consider these party-sized pools, and you have a very close approximation of the amount of air our lungs process every day, 365 days a year for more than 70 years on average. IEQ is thus hugely important to the air we breathe within our built environment. So it needs to be managed, and as the management guru Peter Drucker famously once said, you cannot manage what you cannot measure. In addition, there is substantial empirical evidence indicating that modern humans are spending about 90% of our time indoors. Considering how many live, work, and exercise without ever leaving their homes or buildings within the congested cities around the world, many on the margins of what would be deemed a habitable ecosystem, 90% may not be as crazy a number as it sounds. Even if we consider that in a 24-hour day, we sleep for a third of that time in our bedroom, making sure the air quality in your bedroom is healthy becomes an important consideration in your daily existence. Furthermore, according to the Environmental Protection Agency in the United States, the levels of indoor air pollutants are often 2 to 5 times higher than outdoor levels. And this is largely because of insufficient ventilation in our buildings. There are 2 notable causes for the lack of indoor air quality. Firstly, IAQ has not recently been considered as life-threatening, particularly during the design and construction of buildings. Secondly, it is difficult for an occupant to notice indoor air quality as a problem. When an occupant experiences reduced quality of sleep, their thoughts turn to psychological or other environmental challenges, such as noise, not the high carbon dioxide levels in their bedroom. Today, technology allows us to take control of our indoor environments by providing accurate and affordable indoor air quality monitors. An indoor air quality monitor is the first step to understanding and improving the quality of air occupants are exposed to. It turns out indoor air quality is a rather big problem, killing 1.6 million people in 2017, according to the Global Burden of Disease report. In addition, PM2.5 has been identified as a major concern affecting human health. PM2.5 is an airborne pollutant with the diameter of each particle below 2.5 micrometers. Particulate matter is of interest as gravity tends to act on particles greater than 30 micrometers, resulting in rapid deposition. However, PM2.5 particles remain suspended for extended periods of time, and as a result can travel far from the sources through the likes of wind action. The relationship of indoor and outdoor PM2.5 concentrations can be multifaceted and may be strongly associated with chronic lung disease, respiratory symptoms, and public mortality. Researchers from Harvard University's T.H. Chan School of Public Health revealed that air pollution has intensified the COVID-19 pandemic, with PM2.5 particulates a major component of that. Research conducted in the field of epidemiology revealed that lasting exposure to ambient 2.5 is related to increased morbidity and premature mortality. An experimental study conducted on 355 university students of 4 classrooms suggested that a 100 parts per million increase in indoor CO2 concentration in the range 674 to 1450 ppm was significantly associated with headaches, and this association was independent from other related indoor environmental factors, including temperature, relative humidity, and air exchange rate. Research also indicated that for every 100 ppm decrease in the differential between indoor and outdoor carbon dioxide concentration, office workers experience fewer sick building syndrome symptoms, including 60% fewer reports of sore throat and 70% fewer reports of symptoms of wheezing. It has been reported that CO2 affects decision-making at thresholds of 600 parts per million, which is below the normally accepted comfort range of 1,000 parts per million. The normal outdoor CO2 concentrations are approximately 380 parts per million, although in urban areas these have been reported to be as high as 500 ppm because of the increased human activity. Outbreaks of building-related illness, collectively termed sick building syndrome, among building occupants have been reported in recent decades. Acknowledging that incidence of SBS symptoms are straightforward, its characterization and linkages to an indoor exposure require more in-depth analysis. An impediment of this effort is to determine whether the problem is primarily chemical, biological, physical, or psychogenic. Typically, maintaining allowable IAQ in airtight buildings depends on whether effective ventilation systems are in operation. Ineffective or inadequate ventilation systems result in inefficient removal of pollutants from indoor air, leading to the display of SPS signs among the occupants. Natural ventilation can provide large ventilation rates without the consumption of energy. In addition, combined natural and mechanical ventilation can improve the quality of the environment. So how can technology, and more specifically data analytics, help to improve our indoor air quality? So the aim of the study was to understand the impact a natural ventilation retrofit would have on indoor air quality in a previously mechanically ventilated office building, the hybrid option. The focus was on the data, how it could be used to better manage the quality of the environment in a more active way, with the objectives being to quantify the baseline indoor air quality prior to the natural ventilation retrofit, determine if there were any changes in the IAQ post-retrofit, and evaluate the potential for the IAQ device to provide live data to better inform the facilities manager or even the occupants in such a way as to create a healthier indoor space. Today, we have affordable technology that allows us to measure and then manage indoor air quality. A case study approach was used to measure the change in air quality of an office building before and after the office facade was retrofitted. The building selected represents a typical modern open-planned office building in Port Elizabeth. A quantitative experimental approach was used to analyze the impact of retrofitting openable windows on the indoor air quality of the office. The air quality device remained in the office for 14 weeks from the 18th of June to the 24th of September 2019. The total number of working days amounted to 69 working days, 552 hours. The retrofitted windows converted the office space from an office with only mechanical to hybrid ventilation. The independent variable was the installation of openable windows controlled by employees. The openable windows were in use by employees from the 16th of August 2019, resulting in a 9-week pre-openable window period and a 5-week post-openable window period in which air quality data was captured. An air visual node by IQA medical grade indoor air quality monitor was employed to measure several dependent variables, including PM2.5, PM10, carbon dioxide, and humidity.
Sorry to interrupt you. You have 2 minutes left.
Okay, we're going to run through the results quickly. Carbon dioxide is considered a critical parameter in assessing indoor air quality and ventilation efficiency. A building space that has insufficient fresh air ventilation can contribute to an increase in the level of CO2. Research findings have indicated that worker productivity is improved in buildings with low CO2 levels. An increase in the ventilation rate improves the effectiveness in providing clean air and reducing CO2 concentrations in the building. As mentioned previously, 1,000 parts per million is the generally accepted ASHRAE and OSHA standard. However, 600 parts per million is acceptable. An analysis of the 14-week real-time data revealed that pre-openable window period had 12 incidents in which the office exceeded 1,000 parts per million for a total of 36 hours. On average, office carbon dioxide levels would exceed 1,000 parts per million twice to 3 times a week. Once the openable windows were in use, the office carbon dioxide level did not exceed 1,000 parts per million for the remainder of the experiment. Openable windows controlled by employees effectively reduced the 1,000 parts per million carbon dioxide incidence to 0. In addition, the main source of PM2.5 are vehicle emissions from combustion engines. The research hypothesized that openable windows will increase the PM2.5 levels as the office is located close to a major road. Following the natural ventilation retrofit, the mean office PM2.5 concentrations actually decreased by 22.84%. Thus, despite the close location, the opposite to the hypothesis in fact occurred, proving that openable natural ventilation is still viable even when located in close proximity to high concentration locations. In addition, a similar improvement in PM10 concentrations with an improvement of 18% were recorded. The PM levels would increase as soon as the employees would arrive for work. The levels at midnight were 1 microcubic meter. This suggests that the origin of PM is from usage of the office space. Settling would reduce particles circulating. The addition of additional ventilation thus increase the removal of these particulate matter from the office space. Increasing ventilation is now critical as we continue to fight the COVID pandemic. A simple and fast NV retrofit can provide an instant and significant improvement to office IAQ. High humidity is linked with a number of negative building environment factors, including thermal comfort. Humidity levels are strongly linked with SBS, as causing mold and other pathogens to flourish. In addition, humidity has been shown to increase the possibility of spread of viruses in buildings, including the coronavirus, due to the nature of spread, i.e. small water droplets. In Table 3, the indoor humidity levels for 3 weeks before and 3 weeks after openable windows were installed. It is notable that despite the changes in the outdoor environment and also the increased flow rate from the natural ventilation, only a nominal reduction was seen in the office relative humidity values. This is good for optimal use of the mechanical ventilation and also for potential impacts on SBS through increased mold due to increasing humidity levels. So in conclusion, this research identified that it is essential to measure indoor air quality in an office building, no matter the age or quality of the construction, even more so in a post-COVID-19 environment. SBS is a documented problem in buildings of all ages, but particularly problematic in modern sealed office buildings. Medical-grade air quality monitors are affordable and have increasing accuracy, enabling all businesses to collect meaningful data on the quality of their work environment and to better manage that environment as a result. The need to reduce operating costs in office buildings has driven increased awareness of the potential to use natural ventilation as a mechanism to achieve this. Unfortunately, the perceived poor quality of the outdoor air has been a barrier. However, this study has shown otherwise, and in particular in Port Elizabeth, the outdoor air and predominant wind patterns provide the opportunity to use natural ventilation successfully. Natural ventilation retrofits with openable windows can be used to improve indoor air quality and occupant satisfaction, as well as reduce operational costs of existing mechanically ventilated office buildings. The literature indicates that human subjects who are exposed to 1,000 parts per million CO2 for short term experience marked variations in respiratory movement, amplitude, peripheral blood flow, and cerebral cortex functionality. This study thus proves that you could improve the performance of those humans as a result of reducing the parts per million. The research consolidates current public sentiment on the importance of indoor air quality, providing a sustainable ecological solution to quantifiably improve that quality by data analytics and natural ventilation. And finally, some recommendations. Facilities managers need to manage indoor air quality in order to provide safe and healthy working environments. A first step to improving the management of indoor air quality is to utilize an air quality device to collect accurate data on those environments and to link this through to the building management system or relay messages to office managers. A medical grade air quality device should be used to ensure accurate measurement, and these generally come with an app that can update the information in real time. The indoor air quality data can also be used to inform building users through marketing communication screens in workplace environments, including reception areas, thereby empowering user behavior to optimize energy efficiency and improve occupant health and satisfaction. The climate and site conditions which the building is located should be thoroughly investigated using various digital devices and accessible online weather air quality data sources. Factors such as outdoor air pollution and noise could limit the effectiveness of a natural ventilation retrofit, and therefore data on this needs to be considered in any proposal. Thank you very much.
Thank you very much, Mr. Chris. That was wonderful, actually. That was wonderful. And a very good project for a B-degree student. I think this is nice. Thank you for the IAQ monitor, all the information given on that. And definitely the world can do with lower oxygen levels. That would definitely be beneficial to people. So let me see if there are people with questions here. Anyone with questions? Atlego, you have questions? Atlego.
Thank you. That presentation was actually quite enlightening, considering that as an architect, we need to actually make sure that there are actually window openings to design. Have you determined somewhat the sizes of the openings per room, which are adequate for the kind of ventilation you're proposing?
Thank you, Katlego. The interesting thing here is we had no control over the number of window openings. I do believe we do have some data on the total change in terms of total surface area, but it's very marginal. If I go back, let me see if I can go back in the slides quickly. Here we go. Slide 6. Can you all see the building here? If you can see the building, let me use the pointer. Hopefully you can see. So here's one of the windows from the facade. And the only openable section that was converted is this small section here. Yet, obviously this is in one window, but in all the windows, the same process was followed. And with simply converting that, and you can see where the road is located adjacent to the building. Just with those small amendments, the findings have been generated. So it's a very small percentage in terms of the overall facade dimensions. If we went back to ASHRAE, there are some basic guidelines, but I'm not sure how much data there is linked to that in terms of the type of information that we've just collected. We didn't find a lot that actually spoke to that. I don't know if that answers your question, Katlego.
The question is well answered. Thank you.
Okay, thank you.
Chris, thank you. That was powerful.
Okay.
Yeah. The next.
Thank you.
Yeah, thank you. The next presenter is Katlego, the B2. The title of the work is The Integration of Interactive Elements with Preschool Technologies for Enhancing Wisdom Transference in Sustainable Education. Katlego, please share your screen. Remember, you have 12 minutes to present your work, please.
Can you see my screen?
Yes, I can see it. Very clear.
All right, thank you. This is a presentation of the integration of interactive elements with preschool technologies for enhancing wisdom transference in sustainable education. My name is Katlego Tsimologolebete from the MTech Architecture Professional course at the Tshwane University of Technology. The main aim of this paper is to present integration strategies for sustainable agriculture education in preschool facilities. This is in order to assist in practical wisdom transference from adult caregivers, facilitators, and community elders to preschool children in South Africa. The design strategies aim to encourage environmentally conscious behavior in children by interaction with architectural and agricultural objects and spaces via play and experimentation. The long-term objectives were to include increasing the population of farmers in South Africa, to improve rural livelihoods and food sovereignty so that we are able to achieve education in agriculture, which is morphologically demonstrated in architectural forms. The identified problem was that in South Africa, which is a sub-Saharan country, the farming population is currently on a decline. This, together with climate change, is accelerating the decline of productive farmers, leaving the remaining farmers to reskill themselves in agroecological farming practices for increased yield. The imbalance is deepened by urban environments, which have their roots in agricultural production and import the majority of their food from rural farming areas. This model, as we have seen through the challenges of COVID, is now considered is highly unsustainable, which one can partly allocate to the children being left out of the design process. The approach is mixed method, which was used to develop the pragmatic research paradigm. Ethnographic studies were used in combination with case studies and analytical experimentation to develop a viable set of guidelines for using the design of preschool learning sites in rural and urban environments of South Africa. The paper argues that preschool education, together with the reintroduction of agriculture as part of the built environment, can improve sustainability and resilience in these systems. The approach offers an alternative to current practices. In our understanding of knowledge and wisdom, we all know that children in current and future generations need to access appropriate knowledge to realize their own needs through their lifetime, and as a result need mentorship and skills. Children also need to be encouraged in creative thinking, problem solving, and change creation. The analysis was conducted on a community, which is Khabalatsani View. As a site, it was chosen because of the variety of challenges that the locality and site presented. It's a new developing location which extends from the neighboring Khabalatsani View. The Greenfield site is a local church site and presented an opportunity to re-establish public educational roles of churches and other religious institutions in the area within South Africa. As you can see from the drawing, the site is bordering the northwestern Gauteng and is near Ga-Rankuwa and Mabopane. The population challenges, as one could estimate at 50% of South African population in terms of its proportion of challenges. One can then look at it that the exodus of the patriarchs from the family unit has caused a significant intergenerational gap, which has in turn sparked a massive decline in subsistence farming. The ancient B2 agricultural and architectural knowledge, which enabled migration from the Congo Basin, has virtually diminished, with the young youth being attracted to urban work, which is less physically demanding. The resulting poverty, along with broken families and community structures, has contributed to the delayed establishment of quality ECD facilities in these disadvantaged societies, leaving children unaware of their power to effect sustainable environmental change. The literature findings had to do with the exploration of permaculture philosophy by Bill Mollison, which served to reunite people with their ecological environments. In the analysis, one can find that children at an early age can be encouraged to engage in the diversification of local food systems in the community over time. Westberg stated that preschool children can be taught new food habits when provided with the appropriate environment, while Frederick Frudel's kindergarten model established that it is vital for children to engage in meaningful activities which encourage discovery and learning through enjoyable experimentation. Maria Montessori also concluded, as I quote, "Scientific observation then has established that education is not what the teacher gives. Education is a natural process spontaneously carried out by the human individual and is acquired not by listening to words, but by experiences upon the environment." Possible steps in the readaptation of the current practices. We can adapt historic indigenous practices drawn from the Bantu systems as per the Congo Basin to South Africa migration based on sustainable living within early childhood development facilities. On your left, you can see the ruins of the great Zimbabwe Palace, with the techniques used there being readapted for the construction of stone planters and retaining walls, which can then be integrated into a preschool facility in order for the children to have access to planters where they can generate food. The integration of ancient indigenous wisdom along with modern technologies to allow for the adoption of a dynamic community-centered approach. This includes the Letsema, with the term Letsema being the collective energy usage of a community in order to achieve a common goal. In this example, the aim was to actually harness the energy of the Letsema for the collection of free and low-cost local materials in the site context, wherein sand, stone, and recycled plastics can be collected in the neighborhood in order for it to be readapted for use on the site in the construction processes of the facility. The Letsema can also be used to construct the building using simple transferable methods drawn from history, such as the construction of the stone planters mentioned in the previous slide. More possible steps: one can add a greater economic value to the establishment of sustainable resource management systems in the area. One can also ensure that children are at the center of well-designed learning environments for ecologically sustainability to improve local resilience and anchor the structure of this succession of human civilization. In the integration process of seasonal food growing, one can then also ensure that children are alerted to natural cycles of life and the seasons, wherein the food cycle can be explored in its entirety from seed, soil, preparation, seedling production and nurturing, watering and water conservation, transplanting, plant care, harvesting to food preparation and consumption. One can also include composting facilities where children can see various processes which turn food back into waste and food back into earth, along with the animals and insects that facilitate this process to allow children to establish the knowledge connections needed for nurturing the environment. In the integration of more interactive elements, one can integrate obstacle courses containing child-only spaces to encourage physical movement while ensuring that children rely on one another for support during challenges. As you can see in the image, there's an introduction of a dynamic loop drawing from the ground floor to the upper floor of a proposed facility in order for there to be areas where one can provide integrated areas for sliding and climbing walls. The elevated floor plane can also ensure that kids are able to see beyond the boundaries of the site, thus in enhancing their imagination of the capabilities of the environment. The designed environments can be used to support good responsive serve and return interactions between adults and children and positive relationships between facilitators and participants to promote children and community health while elevating child and adult life skills. One can also provide amalgamated agriculture and architectural spaces to accommodate children for conversation, improvisation, prototyping, and tinkering.
Sorry to interrupt you. You have 2 minutes left.
Thank you. One can also provide collaborative learning environments for children to accelerate the development of a collective intelligence. This can also be done in the integration for pattern recognition, problem recognition, conflict resolution, risk calculation, and programming objects to aid in various problem identification and solving skills. In the image here, this is an illustration of an abacus gate to allow accessibility to multiple children during number experimentation while being facilitated by a knowledgeable adult. Thank you.
So, a powerful presentation, and because it goes into the future, I think it's powerful. But it's not my field. I don't know if there are people here that want to make comments or ask questions about this. Anyone? took out the presentation. Can we still see? Okay. Professor Mira wants to make some comments.
Yes, thank you. Thank you so much, Katleho, and well done. And thanks to the other two presenters. The first presentation, I'm really sorry I came in late there, but I'm very interested in what it has to say. So I'm actually going again through the paper now, and if I have some questions, I'll ask them a bit later. Yes, well done to the second presenter with regards to the focus on, I really liked what he said in that we mustn't focus on one virus, but we must focus on creating healthy environments in general. So I really appreciated that. And if I'm not mistaken, he ended his presentation with change the world.
Yes.
And I thought that was beautiful. And Katleho is speaking about enhancing imagination through these kind of interventions. Katleho, I've probably mentioned to you before that part of the UIA 2014 declaration was that food production needed to be an integral part of every building project. So your project has great significance. You're looking at using technology and this link between technology and buildings and agriculture and food production in facilitating wisdom transfer. I really think that these are incredibly noble aims to have. And yes, and one thing that the previous presenter also said with regards to indoor air quality, and I hope I understand what he implied, was that sometimes small amendments help achieve quite a lot in terms of the criteria that he's measuring. So we need the change in thinking, and we need that change in thinking to help us change the way that we design. So those would be my comments on those two presenters, and I'm going to go back to the first presentation later, hopefully. Thank you so much for allowing me the opportunity.
Thank you, Prof. Thank you for your input. Okay, Katleo, I appreciate your presentation. Thank you very much. Thank you very much, Katleo. Okay, we move on to the next presenter now. Paper 169. The authors are Chijioke Emeri, Innocent Musunda, and Chioma Okoro. Title of the work is a review of critical project management tools for improving construction SMEs project performance. Okay. So let's see who is here now. I don't need it. Now, Chijioke Emeri, are you the one presenting now? Yes. Hello, Chijioke. Okay, maybe we'll pick the next project and then we'll come back to that. Then the next project, which is paper 19, we have Tokozani Mbonani. Tokozani Mbonani, with the paper title, A Narrative Review on Lead Poisoning and Antisocial Behavior in Sub-Saharan Countries. Tokozani Mbonani. Okay, let me announce the first one. Chijioke Emeri, I think we can see you, but all right, let's go to another paper so we don't waste time. Then another paper titled Not the Regular Fit, a Socio-Technical Systems Approach for Designing Eyewear in South Africa. Also, the Masha Nodia. Masha Nodia.
Hi, I'm here.
Oh, thank you. Yeah.
I am not seeing the share icon is grayed out, so I can't share at the moment.
Okay, just hold on a little, you'll be able to share. You can now check.
Perfect. Let me try.
Okay, you can now your screen.
Can you see my full screen?
Very clear also.
Perfect. Okay, so hi, I am Marsha Nadia, and I'm an industrial design graduate from the University of Johannesburg. Today, I will be presenting a paper written by myself and Mr. Angus Donald Campbell that's titled Not the Regular Fit, a Socio-Technical Systems Approach to Designing Eyewear in South Africa. Eyewear is available in various sizes, shapes, colors, and styles, and one would think that you can actually find the perfect pair really easily. But do we really have such a wide choice as we think? In South Africa, there is a scarcity of prescription glasses manufacturers, and the majority of the eyewear frames are imported. What's quite interesting is that the majority of these frames are from a single umbrella organization, which control the price, the design, and even the distribution of the eyewear. But what is even worse is that these eyewear frames are actually designed from a predominantly Eurocentric perspective. So, for example, there are currently only two types of eyewear fit available: the regular fit, which is based on European facial data, and the Asian or global fit, which was developed in a reaction against the regular fit. So in South Africa, a country with a significantly diverse population, there is certainly an opportunity to design properly fitting eyewear. Fit is important since when eyewear doesn't fit properly, it can lead to physical pain, discomfort, and also distort vision. And even in the long term, it could lead to vision problems. So at the moment, there's not a one-size-fits-all frame solution, and frames have to be adjusted to compromise between the wearer's needs and what the frame actually allows for. Another thing to mention is that there are other systemic challenges in South Africa with regards to the medical industry and the accessibility to eyewear that also play a significant role in the process of how someone would go about the process of getting prescription glasses. So we are sitting with an issue where eyewear frames are not meeting the needs of the South African context, and also a system which is complex and making the accessibility to prescription eyewear problematic. So this paper explored a design research study that was undertaken during my master's degree to address some of the local eyewear complexities through the design of an eyewear frame that is more suited to the context of South Africa. So the central research question of the study was, what are the problems of eyewear currently available in South Africa, and how could eyewear be designed to better consider the social and the technical complexities of the South African context? To answer this research question, the theory of socio-technical systems was selected as an appropriate theoretical framework. So for the study, the socio-technical system referred to the organized system of people and technology, so the social and the technical aspects, that is arranged in a way to accomplish a specific task. So in this case, to improve human sight. So an existing model was adapted to suit this study. The technical factors of the design process was considered through an appropriate technology, and it acknowledges the context of the product use. And the social factors were considered through a human-centered design approach to ensure that the specific needs of the people who will be actually using these products were met. The human-centered design toolkit by IDO was used as a model to undertake the study. So the model outlined three main phases: hear, create, and deliver. In the next section, I will explain some of the main research methods as well as the key findings of each phase. During the here phase, problems of eyewear currently in South Africa were investigated to see if the current frames are actually meeting the needs of the South African context. So a relatively small sample size of eyewear wearers and experts within the field of optometry took part in the study due to the qualitative nature of the project. But from the findings, it was very clear that the eyewear industry in South Africa is a very complex system and that not all of these issues that emerged could actually be addressed. But as industrial designers, our obvious solution was to design a product, in this case,
Hello? Can you hear me? Asha, can you hear me? Something is gone wrong with yeah.
Is there any way to communicate with her and tell her that
Yes,
we can't?
I've just got a message from Marsha. Her power's just gone out, so her UPS is just about to kick in, and she'll continue the presentation hopefully very shortly.
Okay, wonderful.
Wait for her.
hi, sorry, I'm back. My power just went out.
That's fine. You can just continue. You need to share
Perfect.
the screen.
Let me just try and present again. I'm so sorry.
No problem.
Cool. Can you see my presentation once again? Perfect. Okay, cool. So to resume my very passionate speech, I'm going to try again. I'm going to start with this slide again. So yeah, basically from the findings, it emerged that the eyewear industry in South Africa was a very complex system and that not all of these issues could be addressed. But as industrial designers, the most obvious solution was to design a product, and in this case, it was an eyewear frame that would attempt to address some of these complexities. So it was identified that the eyewear frame design had to accommodate the following factors. It had to suit fitment needs that requires that the frame would actually meet specific facial feature needs. It meant that the frame had to be able to allow for the participant or the user to select specific aesthetic elements of their frame design. And it also had to consider the cost and consider what people can afford for their frames. And also it had to consider eye health needs, which means that the frame had to accommodate different lens prescriptions. So in the end, this meant that the frame solution had to be adaptable to accommodate diverse needs. And mass customization was identified as a way to achieve this. In the create phase, solutions were practically explored to determine how technology could be used to create adaptable eyewear for the context of South Africa. To meet the fitment needs, facial anthropometrics of the participants were needed, and various technologies were explored, such as 3D scanning which showed promising possibilities, but it was also found that this technology is relatively inaccessible and complex to use. So, suited to the principles of appropriate technology, we therefore opt for a manual measuring method, which is based on the Fairbanks facial measurement gauge. And the facial gauge was not accessible during the study, so we adapted and simplified the multi-purpose tool into a collection of 6 individual measurement tools that were produced by simply laser cutting cardboard profiles, and then we printed some measurements on them. So when these tools were tested, it also emerged that the Fairbanks facial gauge was designed for particular facial sizes and did not quite suit the facial structures of the participants in the study. So we then had to modify our tools to accommodate a wider range of facial structures. So this also means the tools that are being used to measure faces are suited to a particular facial structure. By using the measurements, facial measurement grids and cardboard prototypes were created for each participant. And here you can actually see how much the cardboard mock-ups differs from the participants' faces, so especially on the nose area. To meet the needs of the aesthetic preference, cost, and eye health needs, each glasses wearer had the opportunity to customize their frame design according to their preferences. The final design was basically an adaptable frame that considers some of the social and the technical complexities within the South African eyewear industry. The final frame consisted of only a few parts that could be produced locally, and the frame was made by laser cutting profiles out of 0.5 stainless steel sheets. The reason for this was due to the accessibility and also the availability of both the material and the technology in South Africa. It is also easy to create custom products with the manufacturing method on a relatively large scale. So although 3D printing could be used as a mass manufacturing technology, it was not pursued in this project because the technology was not available and also due to its cost. During the deliver phase, a final frame prototype was created for each participant's unique needs, and they had to test the frames. So for the participants to fully test the efficiency of the frames, their specific lens prescriptions were fitted into the prototypes by an optical technician. And a problem that actually occurred during this process was that the machines that's used for fitment, lens fitment, it only accommodates standard frame sizes. So the technician actually had to manually calculate some of the correct data inputs. So this provided more evidence that the inappropriateness of the standard frame design extended beyond the frames themselves into a broader socio-technical system of the South African eyewear industry. The overall response from the glasses wearers after wearing the prototypes for a while were very positive. All the glasses wearers commented that the glasses suited their face better and they enjoyed wearing it more because they actually chose the color and the style of the glasses. And some even said that the glasses or the prototypes fitted better or that it felt more comfortable than the current frames that they are wearing. So in conclusion, although the study aimed to address the systemic challenges within the eyewear industry in South Africa, there were a few limitations that I have to acknowledge. So due to the complexity of the system and the time frame of the study, it was impossible to do in-depth research of the entire eyewear system. There were also quite a lack of rigorous data, and only a small sample group of participants partook in the study, so the data cannot be generalized. But there is an opportunity for further quantitative studies to generate more representative data. So in conclusion, the project is only one example of how products are often imported into countries where the context of their use are not considered, meaning we are compromising how we use and interact with products. And particularly in this study, we are often wearing uncomfortable frames because there are no other option to choose from. So with further research and development, especially through the application of appropriate technology, there is an opportunity to create meaningful products that's better suited to the context of their use. Thank you.
Thank you, Marsha. That was powerful. Thank you for that. Customized glasses. I think the best technology you can adopt for customized products is just the 3D. Although you did mention that it's not available in South Africa, probably for this type of thing, but I think 3D is available. If you search for it, it will just be perfect because use computer software and then you can use it to make diverse products without wasting so much time. I mean, per person, you can do it with 3D printing. And then your measuring tools, actually, they are commendable. I saw you said you use laser cutting to cut those things. And then, yeah, and then they also have shortcomings that you mentioned the shortcomings also, but nevertheless, to me, I think it's commendable. You understand? And not only that, I think if you decide to market them, they are good. They are very good. It will be generally accepted. And 3D machine is just your best option. It doesn't work with all materials because the research is still ongoing, but it does work with quite a number of materials. The range of materials are increasing every day that 3D printing works with. Apart from that, very good research. I commend you for that. Can I see anyone that wants to add comments, questions? Prof. Amira, do you want to say something? No, I don't think she's.
I can't unmute. I'm trying to unmute. I can't
No,
unmute.
We are hearing you now.
Oh, is it? Excellent. Yes, no, I did write it in a chapter that I was complimenting Marsha. I think it was an excellently structured argument and presentation. Beautiful looking product. And I love the way that she recovered so quickly from the power cut.
Thank you. Yes, it took me a little bit because I was kind of prepping for it. We've been having issues, but yeah, so thank you for allowing me to pass it back.
It didn't look like it shook you at all, but a beautiful presentation. Thank you so much. I actually have to leave now, so I just wanted to acknowledge the first presenters. I've actually just quickly scanned through their paper, and I have so much that I could discuss on that in terms of the relevance to our context, the need for labor intensity. And I'm sure that a lot of it has been discussed already, but hopefully we'll connect at another occasion. But at least I've made the effort to go and revisit their paper. So I need to leave the session now, if you will excuse me, Prof. Bukula.
Thank you. Thank you for your contribution. Thank you so much.
Thank you.
Okay. Thank you, Marsha. Thanks. We now go to paper number 169. I see that Chijioke is available. Chijioke, are you there?
Yes, good afternoon.
Good afternoon. We've been looking for you.
Yeah.
So we come.
Can you hear me, Prof? Good afternoon.
Yes, I can hear you clearly. We call on you now to present your work, a review of critical project management tools. Construction, SMEs, project performance.
Yeah, I'm ready. I'm not sure whether the network. Yes, Prof. I'm not sure whether the connection is from here, the network problem. But if you can hear me properly, then I will appreciate. I can proceed.
Yeah, please proceed.
Let me share the screen.
Share the screen. Let's just.
Is this screen one? Okay. Are you seeing the screen?
Not yet. Try again.
You can see the screen.
Yes, it's coming on. Trying to come on.
Can you see the screen, Prof?
Yeah, it's trying to share, but it's not yet shared. Trying to.
Okay. It's coming.
Trying to share the screen. We should just go on. Prof, do you want to say something?
I'm not sure what network is doing today.
Hello, Prof.
Is it fine?
No, it's not yet fine. Once it's fine, I'll let you know.
It should be the first one, right?
Yeah? Hello, it's not yet sharing the screen. We're still waiting for you to share the screen. Okay, can you present? Let us hear what you've got to say. Maybe while you are talking, the screen will come on.
And let me check. Can you see my slide?
No, I cannot see anything. I just see that it is trying to load, but it's not coming on. That's why I said you can keep talking. Just keep presenting. It will now come on.
Is it fine?
No?
It's fine now.
No, we will tell you if there is a change.
I'm seeing signs here. I'm not sure whether it's fine.
The minute we see a change, we will let you know. You just present. I'll say the same thing. Once I see a change, I'll let you know. Just present. It's not fine. It's trying to be, but it's not yet fine. You just present. The minute there is a change, I'll let you know. Yeah, now it's come on. It's fine. Now it's fine. It is fine now.
Now it's fine.
Yes, it is fine.
Okay, thank you.
We can do the presentation.
Good afternoon, everybody. My name is Chijoke CEML. I'll be presenting on a review of critical tools for improving construction SMEs project performance. I'll be talking about the statistical background, the research method, implications of findings, and conclusion. The construction SMEs are fraught with inefficiency, poor improper planning, scheduling, and control in the project execution, partly because of inadequate usage of project management tools. There have been some negligence in the construction industry, and there are no massive project management tools. They make promises, unrealistic promises without proper analysis. So these things are detrimental, and very little attention is being paid to the status quo improvement. And the detriments of these shortcomings are the project delays, cost overruns, poor quality. And leading to customer dissatisfaction. And when there is customer dissatisfaction, there will be loss of contracts, and then which will result to unsustainable business growth and even liquidation, which are also detrimental, which is detrimental to the economic growth of South Africa. So the aim of this research or this paper is to identify the tools that are relevant for meeting project deliverables and improving performance efficiency. Adequate use of project management tools is a concern in the construction industry, especially in this 21st century. We can no longer rely on conventional approaches to project management. We need to focus more on the specialized tools, which will give us maximum outcome or positive outcomes. Traditionally, projects within the planned time, budget, and quality. Tools are different from techniques. There have been some misconception in the industry, even in research. People use the term tools and techniques interchangeably and some synonymously. But I would establish the two definitions. First, I'll talk about the techniques. There are systematic procedures to achieve project deliverables. Tools can be defined as software, documents, or design used in connection with the project management tools are important to the performance of construction SMEs, which plays a huge impact on the GDP and contribute about SMEs in the construction industry are major platforms even for job creation to solve the prolonged unemployment rate of about 27.7%. Performance is paramount. We need to see how to improve the construction performance of the SMEs. On the research method, this is a literature review. So various sources were consulted, including journals, conference proceedings, dissertation thesis. Databases including Science Direct, EBOS, Emerald, Sabinet, Google, and Google Scholar were consulted. Materials were selected based on the position of relevant keywords, including project management, performance, SMEs sources, construction industry, and tools. The identified tools were ranked according to the frequency of occurrence amongst the sampled studies. So let's look at the findings. We see some tools that took preeminence in the literature. We have Gantt chart, project charter, control chart, decision tree, checklist, cause and effect diagram, Pareto diagram, progress report, network diagram. I will just talk briefly on them and where they are used and then the objective they are to achieve. So on the Gantt chart, the project manager used this tool to present the project schedule in a chart format, easy to understand. It shows each task as a horizontal bar whose length is proportional to each time of completion. So it can be used in the project cycle, planning and the execution phase of the project. It can be used to achieve time outcomes. So it's used for time management. On the project charter, it refers to a statement scenarios, roles and responsibilities, and identifies the main stakeholders. It improves communication among project parties to a great extent and allows progression to be aimed at attaining industrial best practices. So it's essential for planning phase. Control chart is used. It functions also. It schedule variances, volume, and frequencies of scope changes. Is a graph used to study how a process changes over time so as to control and improve the process. Can be used during execution phase of the project, and is a special tool for quality management. Decision tree portrays decisions and their possible consequences in a tree-like model, including chance, event outcomes, resource costs, and utility. It helps to determine the worst, best, and expected values for different scenarios. So it's a key. It's very important. Can be used in conceptual and construction phase. Is a special tool for risk management. On the checklist, well, many of us are popular know about checklists. It can collect data, and the collected data may provide a platform for subsequent analysis. It helps translate opinions into facts. So it can be used for conceptual and execution phase as well. Is mostly used to achieve quality objectives, and can play its part in terms of risk management. We have the collected data may provide a platform for subsequent analysis. It can help translate opinions into facts. So it's key, can be used for planning and execution phase, is a special assist in the breaking down of major problems so as to pinpoint the most significant parts, used in execution phase and the quality objective, and can be used to achieve quality objective. The report can clarify in detail the activities and tasks that have been undertaken and the milestones that have been reached towards the completion of the project. It can play its part during communication management as well. It can help keep the project on track. So it's essential. We have the network diagram, which can work in tandem with for the network diagram, it can help to calculate the path, the critical of activities that should be followed, that has to follow. So it's a very key chart. It's a very key diagram. With when adequately done, you can actually pinpoint the events that you don't have to miss. Because when you miss that event, it will be very costly to the project. There will be a lot of side effects. So it helps you to know what to keep your priorities in check. So we have the scope statements, which can be essential for scope management, and is crucial at the conceptual phase and planning phase for proper definition and control of the project, to ensure that the activities were not deviated from, but rather tailored to achieve the desired project goals and to meet objectives. So it's also a key. We have the milestone chart. The milestone chart is also another key tool for using planning and execution phase of a project, can be used for time management. And the chart focuses on planned critical events that are scheduled to happen at a specific times in the program. So such events could be the inception of equipment deliveries, reviews, or perhaps approval dates. So it helps you to pinpoint the milestones regarding the project. We have the organizational chart, which can give you overview. You can show overview of the organization. Demonstrate the connection between the tax members together with characterizing their obligations, duties, and specializations. Elaborate on all of them, but we are familiar with the flow chart. We're familiar with flow chart. flowchart can be used during planning and execution phase and to achieve quality. And we have is very clear. The performance report can be used in execution phase, and all right, we have the activities list also, and then the project closure documentation, which can be used in project closure of the project life cycle. And we have the pay chart, which was with program evaluation review technique. Is a special technique even for time management, and it's related with 3-point estimating as well. Can be used also for in terms of costing. We have the risk log, which helps you also to identify uncertain events that may significantly affect project performance. So it's key. It can be used even throughout the project, but especially on the execution phase of the project, we use it for risk management. So we have the drawings. We have the AutoCAD tools, the software that can help you to draw, can be used. Obviously, the software, it can also keep you track. It's also associated with the BIM modeling tools as well. And we have the BOQ, the bill of quantities, which the BOQ, which reflects the.
Sorry to interrupt you. You have 2 minutes left. You have 2 minutes left. Hello, Chijioke, can you hear me? Chijioke, hello?
So, project management, the network is. Thank you. The project management tools for space. Yes. So here is the table, what I've already discussed. Hello, Prof. I can hear you now. Should I proceed?
Please go ahead and conclude. Just go ahead and finish up.
We established the Gantt chart, project charter, control and decision tree, other notable techniques, other notable tools, checklists, cause and effect, so that use of tools in project execution should be given priority to achieve project. It's key. It can help in changing even the psychological disposition that which entails some people in the industry, they even think about they have this conception that planning, but the advantage of these tools will yield tremendous product. Project objectives, when achieved, increase overall productivity of the organization, which in turn affects the economic abundance of business, not the basic product of any economy. Being a literature review, findings of the study may not be exhaustive, therefore, to determine the critical tools used among construction SMEs to improve project performance. Thank you.
Thank you, Chijioke. Wonderful work, which is basically review work. The information provided through the review actually assist quite a number of researchers in their research, whatever they get to do. Then we see the long list of
thank you
that you have put together, and you have information on each of those two. I say that is wonderful, and that becomes very useful. One thing I know about review papers, so some of the review papers that I have, they have the highest citations. They are easily downloaded. So at work, definitely would have a lot of following to information provided. Thank you. But let me check now if I have people that got questions for you. Is there anyone with questions or comments? Can I see your hands up? Your network is really, really bad, okay. Well, I don't see anyone with questions for you. Thank you for your contribution. It will go a long way to be very useful researchers. Thank you. And at this point,
Thank you, Paul.
okay, at this point, we don't have any other paper to future because the last paper, I don't see the authors here. We have two more paper, but the authors have not shown up. Therefore, I now declare the meeting closed for today. Thank you for coming. We appreciate your presence here. We thank you for your time. And we do hope you have learned through all the information provided. Thank you and see you. You can join up with other meetings that we have. Still have quite a number of meetings for today. You can just join up with it. There is still a poster presentation that will go from 4 to 6. Please join up with those ones. Thank you for your attention. Thank you.